Okay, welcome to Nested Loops. We're doing chapter 9 today, and I'll turn that right over to Scott. So we'll have Scott present. And then, use my mic. Should I turn my mic off? You use your mic. I don't know how good my mic is.
Your mic is on.
What? What's that?
Forrest's mic is on.
Yes, I was wondering if we should switch when he goes.
Yeah, how is my voice? Is it okay?
Sounds pretty good.
All right, well, we'll try it.
We'll start this way, and that way it'll be easy to switch back and forth. All right, chapter 9, the strategy pattern. And it's a nice pattern to implement stuff that might be a little more complicated. So we'll go through it in this chapter. Okay, chapter.
Okay, I already changed my mind. Switch.
Switch. Okay.
Thanks for the update.
Yes, I'm muting.
You turn your volume off. Hold on.
Laptop volume off. On Forrest.
All right, no feedback. Is this better?
Awesome.
Yeah, your sound is gone.
Way better.
Oh, I need to turn mine on, don't I? Okay.
Sounds much better.
Is this better? Good. All right, glad I made the switch. Okay, in this new case study, we're going to use a strategy pattern to handle different countries' taxes. So we'll get into that. So we're going to return to the problem of new requirements, do a review, and review the approaches to handling new variations of an existing theme. We're going to see which approach is consistent with the Gang of Fours philosophy and why, which was good for me. It kind of reawoke something that I hadn't thought about for a while, having not gone through the Gang of Fours book in quite a while. The new case study will describe the strategy pattern and how it handles the new requirement, and we'll then look at the key features of the strategy pattern. Okay, so going to the 50,000-foot view, many times in life and times in software applications, what is the general approach you're going to use to perform a specific task or solve a specific problem? If you aren't thinking about this, and this applies to me too often, is you may end up just doing it, and just doing it using the easiest way. But the problem is that this can make things really hard to maintain after a certain point if you lose control of it. So the book has the example of the 3,000-mile oil change, and how if you don't change it till 30,000, you probably might as well forget it because the car's already fried its engine. Or the desktop filing system, where you don't put stuff in a place where it's secure and accessible, and pretty soon your desk gets too confusing. Disaster, also translated to, oh my God, our application is legacy, comes from the long run from suboptimal decisions made in the short run. That, and sometimes it's just plain difficult to choose good solutions if you are time constrained and you are dealing with existing libraries and that kind of thing. So, but when you can, it's worthwhile to take a look at how can we make this more maintainable. So the chapter goes through the excuses. The first one is the one I think most people suffer from, and that is you don't really have your head around how the new requirements are going to change things. And you get impatient because you don't have a way of answering that question. So you worry, okay, we're going to be, I don't know how long I'm going to be in analysis. And if we get through analysis, we might not know how long we're going to be in design. And if we don't know those things, then you worry about whether you have the budget to do it. And then on top of that, you have pressure from the customer through the management, through the project manager, through blah, blah, blah. And you go, oh my God, I can't even think about it. So obviously we'll get to it later. And the problem with this is that it's an unnecessary pathway to panic. You sit there and you go, well, I either am going to overdo this or I'm going to underdo it. And the problem with underdoing it is you kind of get this sense that you're putting holes in your own ship and you just need to anticipate when you need to change jobs because your job's going to get impossible. Okay, so yes, there is pressure to deliver and not maintain, but that doesn't necessarily mean that you can't. And there may be much easier ways to tackle opportunities to make your project more maintainable and changeable. And so this chapter is going to go into some of these, some initial, I call them illuminations on how to do this. So it's going to debunk the belief that it's more costly to design for change than to design without worrying about change. So he talks about if you actually consider how a system might change over time, you may, hopefully, probably get a better design becoming apparent. And it actually takes less time because if you can break your programming problem up appropriately, it can become significantly easier to design and implement. And then for your efforts there, oh, you also get a much easier to change set of code. And these things can more than compensate for the additional time to see how to do it right. I think for me, what was illuminating about this chapter is, okay, you know, one of the top objectives I've heard for how to do software is to design for change. And that all sounds mighty good, but unless you have methodologies in place for making choices to design for change quickly, it kind of becomes this abstract pie in the sky thing. You kind of say, well, it'd be really nice if I could design for change. But again, going to the previous part of this chapter, you con yourself out of attempting to do it because you think it's too hard. So here are the principles that the Gang of Four uses that give you a kind of a methodology on how to go about it. And that is, always look for opportunities to break things up to interfaces so that you're focused on those rather than the implementation. As we'll see later, the implementation can fall out of the interface if you get that right. And that's what one of the things design patterns are set up to do well. Watch out for when you use class inheritance, and if you don't have a good reason to use class inheritance, use object aggregation. And here's a key thing that I found valuable, and that is, at each point of your implementation, you're going to be implementing something in a part of your design. Consider carefully what should be variable. And if you can identify a single variableness, that opens doors on finding a pattern that's really going to enable you to have an easily changeable design. So what's recommended is don't focus on the cause of redesign. Kind of look at what might force a change to a design and see what that encapsulates in terms of, you know, what's variable, and then encapsulate that. And my experience is if you get that right, the rest falls out almost for free. So what he's suggesting is an early summary, and the book will cover a lot better examples of how to do this, but consider using the strategies even early, as in this chapter of the book, and learn to consider whether designing and implementing them will save you time or not, and you start getting experiences not only as to whether to use a pattern, but over time in the book, what pattern to use. And you can expect to do this without worrying about it costing you much extra in the early going. Certainly enough to make it worthwhile. Okay, so then he then launches into the strategy pattern. And the precaution is don't just throw strategies around blindly, but look as to how you can test the value of the alternative design and examine how well it is a good object-oriented design approach. And what I like about this chapter is he starts giving some qualitative and even quantitative approaches to decide whether you're going to have something good to use a pattern on. So in order to do this, he uses an example, an e-commerce system, actually a part of it. And what he's going to focus on is an order processing system for an e-commerce company that's international. And the focus of the international is he's going to have to do sales orders in many different countries, and what he's eventually going to focus on is different countries have different tax policies, and so he's going to look at how those complex tax policies can be managed. On the way there, he talks about the top approach is he has a task controller that responds to these events, a family of which are having to do with a sales order. And so he says, okay, one of the preconditions is the order is filled out using some kind of GUI system. The system will then have to handle the tax calculations, and then when it has those things, it processes the order and prints the sales receipt. And he talks about, as you find these job requirements, you start identifying classes to handle them. So for example, although the sales order would not necessarily print itself, it would hold the information about the sales orders so that some other object could invoke a sales ticket object that prints the sales order. So he's kind of giving a 10,000-foot view of where we're going. Okay, so now what he's doing is he's saying, okay, given this, let's think about what happens if we have to handle a new requirement. And the one he identifies is what happens if the taxation rules change. And so he says, okay, at a minimum, I have to add new rules for computing these taxes. And so then you come back to the question of is, okay, well, what approach to implementing this code will make it the easiest to add the new taxes and change taxes and all around manage that? How do we keep it from being what they used to call a big ball of mud? So here are the choices that I think we've all used at one time or another. The standard copy and paste, everybody's used it. We can consider that. We can consider kind of a variation. We can just put a lot of logic in and switch to calculate what set of tax operations we want to use, and then we can use function pointers or delegate it somehow, or we can use kind of a strict inheritance of what we've already got to make a derived class that does it the new way, or delegate the entire functionality to a new object. So you know, this is the kind of, I don't know what I'm going to do, but here are the things I can consider. So let's go through and see which ones are worth more consideration. The first one we know, copy and paste. Anybody who's done that and maintained it knows that, no, we're not going to do that. Particularly in something that, you know, is going to grow. If we know simply that we're only going to have to calculate taxes for, say, 2 entities, we might consider it a little bit. But we know that's not going to happen, that this is an international thing, so there's going to be probably many more than 2. So we're not going to do copy and paste. Kind of the same thing for switches, case statements, that kind of thing. He goes through a very good illustration of it, that if you start out with, let's say, the US and Canada, we've got 3 different things. We've got to switch, you know, handle. We've got to handle a tax switch. We've got to handle a currency switch. We've got to handle a date format switch. We've got a lot of implementing the same case statement across different parts of the problem. So there we already have kind of a copy paste, and this gets inflexible really fast. If we have Germany, we may have to add language. And now the code looks like this, and okay, it's getting ugly, but we still go with it. And then all of a sudden we realize that in Canada, it's a bilingual country. And so we're going to have special logic inside the case statement to do that. And now he says he likes to call it switch creep. I think a better term is switch nuclear fission, because it can explode on you really quickly and become very, very demoralizing to maintain. I think all of us at one stage or another in our careers have been there. Function pointers and delegates in C++ and C# can be used to hide code. However, they don't necessarily work down here when you have the, you can't retain state on a per object basis, and so you have limited use. And I had to read that several times, and what this is that, you know, functions don't hold state. So you have no place to hold the state. So you can't really use that.
What JavaScript functions do?
Not between invocations. That's the problem.
Well, not if you pass the function, it uses the same.
Yeah, if you pass state to it.
No, if you pass the function. JavaScript object, you can put JavaScript object is another object.
Yeah.
It works the same. You could basically duplicate something strategy like by embedding.
Yeah, you start
into the function.
You kind of start going into a more functional programming approach.
That one I'm just saying.
Yeah.
No, I'm just saying. C++ and C functions can't.
Mm-hmm.
But JavaScript.
Okay. Inheritance. It's got a bad rap in that, you know, inheritance is really useful for certain things, and your maturity as an object-oriented programmer is to know when inheritance is a useful thing to do and when not to use it. If you use it incorrectly, it makes a mess. If you use it correctly, it can be quite powerful and useful and actually aid to keep things clean.
I want to ask, anyone have any? I read so many. Oh my God, inheritance evil. And I want to know, have I just coasted my entire life and not hit that? So does anyone else out there have any like, oh my God, this is such a terrible? I think I've seen some problems, but nothing. When I see the literature, it's oh my God, so terrible, so terrible.
I can say that I have overused inheritance,
Yeah.
where like either injection or aggregation would have been better.
Mm-hmm.
Mm-hmm.
So I don't think it's evil, but it does come with warnings, I guess. It's an easy thing to do. It's generally it's the easy things to do, but because it's the easy things to do, sometimes you can do it when it's not needed
Mm-hmm.
or it's not helpful.
Yep.
Okay. There you go.
I know in learning small talk, inheritance was a terrible problem because none of us really understood it, and it wasn't taught well back in those days. Object-oriented design was not taught well, and so very few people. So we didn't know how to do it, and we just misapplied it all over the place. Ignorance is not good in programming, but everybody starts there. And he notes this. He believes that many of these problems we're experiencing today is that for years object-oriented programming was not taught well, and I was part of that. I went through the J2EE class hierarchy, and I mean just so much early object-oriented design that was touted as this is the way you should do it was actually terrible. So it's interesting to come back and see just how much better the training is on it. Okay, so in the strategy pattern, he would like to reuse the sales order object to handle these kinds of taxes. So he could treat tax rules like a new kind of sales order, only with a different set of taxation rules. And so he does what we've already seen in previous examples. He just starts inheriting over really the wrong class, sales order. And he notes this will cause problems. It starts to work, but it has serious limitations that will block you from going further on. Because you will start having inheritance hierarchies trying to implement different categories of change. You know, so if you've got date format, language, freight rules, taxation, all these things are varying, and you're trying to handle that in a single inheritance hierarchy, as we would have to do if we're piling everything under sales order. Very soon things get unmanageable and your permutations explode. I remember my early years in object-oriented, this was a constant problem. We didn't understand that, and nobody was talking about it much. So you get these tall inheritance hierarchies, and it degrades rapidly. Okay, so finally, how can we use a design pattern to take a different approach? And here he starts saying things that he hits over and over again that I find to be very useful, and that is, what should be the variable in your design? Not your overall design, but in this particular part of your design that you're trying to implement. And what you should do is encapsulate the concept that varies, meaning keep this separate from everything else so that you don't get the interactions with everything else that really doesn't care about this particular focus part of your design. And this means that in order to get it there, use object aggregation over class inheritance. Aggregate it out. And then if there's opportunities to use inheritance in what you've aggregated out, it actually might turn out to be useful. So he summarizes it. He says, okay, find what varies and encapsulate it in a class of its own. And what I'm getting is find the variable singularity that's changing and encapsulate it. In other words, you only want to handle one thing changing at a time, one category of change at a time, and then move all of this stuff into another class. So in the example, what he's focusing on is how do I take care of the tax rules varying so much from country to country. And what he's recommending is using these principles, create an abstract class that defines how to accomplish taxation itself, and then derive concrete classes for each one of the variations. In other words, create a calculate tax object, and that's the interface to accomplish the task. Identify the information that the calc tax object and its implementations will need. And now you've got a much, much simpler, straightforward, easier to test, more reliable design instance. So here he uses the UML diagram, and he introduces the method that CalcTax is going to implement, the items sold, some class that gives it a, what an item sold means, the quantity, the price, and then return a double for the money. I kind of looked at that a little askance. I'm wondering why he isn't using something like a currency object, but that's okay. He's not focused on currency. So, okay, so now favor the aggregation. Now that he has it, he knows what he wants to do. He separates it out. In other words, instead of making different versions of sales orders, he's going to contain the variation by aggregating to a different object. He'll have one sales order class and have it contain the tax class to handle the variations. Here he implements it in Java, very simplified. Here's a task controller that has a process. He calculates what the tax rules for the country are, and he invents a new sales order, and then he asks the MyTax to process the sales calculation as part of the sales order. In the CalcTax, he will implement some tax from some different country. He then, in the sales order, in the process, he says, calculate the tax. And all it has to do is to use the CalcTax instance to use, calculate the tax amount, given the item number and the price, and return the tax. And then the process can use the tax from one object for all countries and figure out the sales order. So that's what he wants to do in his CalcTax, which you can see down here is an aggregated relationship. He declares the CalcTax as an abstract, and it's going to do the tax amount calculation. And then he has a Canada tax and a US tax, and each one of these implement the taxes for however that country implements taxes. And everybody's running complete deficits, so there are no taxes because nobody wants to be taxed. So everybody's going to be zero. And so you know what the tax calculation for the sales order is, and we're off and running. Now all we have is the calculation tax and the concrete classes underneath. That's all we have to concentrate. We can implement the tax calculations, and we know we're doing so probably in the most easily done manner that we're going to be able to identify. It feels right to me anyways. Okay, here's a little detail on noting the types of the arguments sent in the method in the UML diagram. Okay, so here he's explaining it. He has a fairly generic interface definition for the CalcTax object. that becomes an abstract method. And so the saleable class determines saleable items and how they are taxed. The sales order would give that to the calc tax object along with the quantity and price, and the calc tax now has everything it needs. So we've defined the boundaries of the problem here. This ends up improving the cohesion, and yet we still have flexibility. Sales tax is handled off on its own. If he gets new tax requirements, it's very clear where those tax requirements go in. He just has to derive a new class from calc tax. Like if you get a new country that you're marketing and selling in, like Uruguay, you just implement a class for calculating taxes for Uruguay. And now the responsibilities are concise. We have an idea of, okay, we have one place to calculate the taxes. He then goes into considerations as to, okay, the tax calculation still needs these three items, the items itself, the quantities of each one, and price. So you're given an opportunity to figure out in general, how am I going to get that information? And he says one option is to have a configuration object. So sales order says, okay, I got this calc tax. Let me go to configurations, get the remaining information, and I can now have enough to invoke this calc tax object and its method. Okay, so we have the inheritance haters. Who said, well, this uses inheritance. And yes, it's true. What I got from this, though, is inheritance can work quite well if you're maintaining a single variable and with what's changing. And that's because your things that you're attempting to calculate on have a single range. And since we've essentially got single inheritance, I'm not talking about C++ in this case, but a primary single inheritance, it's a good matchup. And so inheritance is going to be not only not dangerous, but it's going to be extremely useful and efficient and easy to understand. So it's a good matchup. So what he's emphasizing here is, since he's not doing it off sales order, he's favoring aggregation so that sales order doesn't have to worry about it. All he has to do is worry about connecting with the aggregate class, which will be the sales tax. So then the protest is okay, well, aren't you just pushing the problem down the chain? And the answer is yes, but that's beside the point. What you're doing is you're simplifying, you're isolating the complicated program into component parts, and you're keeping the sales order, which is kind of a management object. You're minimizing its complexity and letting it focus on how it ties all these pieces together. But then aggregation says, well, you can just kind of delegate to the aggregates the specifics of how you're going to implement these things that are only tangentially a part of what you're trying to do. So, i.e., this will scale, and using inheritance in the wrong place will not scale, and it will cause lots of problems. I liked this analogy that using the strategy pattern is very similar to the process of normalization in databases.
No, it's not strategy. It's
moving, delegating.
It's moving variance that is the same as normalization. Okay, so he then goes into a formal definition of the strategy pattern. And what he basically is saying, it's a method of encapsulating an algorithm in an abstract class and using concrete classes one at a time to
accomplish different implementations of the same algorithm. And the advantage is you have a family of algorithms, encapsulate each one, and then the derivatives of them are interchangeable. So it allows the algorithms to vary independently from clients that use it. You don't get everything tied up in one or too few things. This goes back to the introduction of the book, in which objects, if you focus on objects having responsibilities and exchanging messages, this works very well in that definition. So different specific implementations of these responsibilities are manifest through the use of polymorphism. And so if you have several different implementations of the same algorithm, polymorphism works well. And separate those behaviors that occur in the problem domain from each other, decouple them, and that way the class that's responsible for each of those behaviors can be changed without adversely changing the others. So the features are, it allows you to clarify your intent, different business rules or algorithms depending on the context in which they occur. You select an algorithm based on the client making the request, and the client will pass something that is a kind of single variable concept to this algorithm, meaning you got to choose the right implementation of the one rule or algorithm. If you don't have multiples, then you don't need a strategy pattern. And so it's really nice. It's easy to see whether a strategy pattern is appropriate to your problem or not in this way. So you separate the selection of which algorithm you have from the implementation of the algorithm. Each implementation of the algorithm doesn't have any idea why it was selected. It just does what it's supposed to do. The strategy specifies how the different algorithms are used, gives it the condition by which they're selected, plus any additional information. Concrete strategies implement these. The context uses a specific concrete strategy based on a reference. And the context and the strategy interact to, context gives the algorithm enough information to accomplish itself. And then, so consequences, a family of algorithms is well defined by the strategy pattern. You don't need switches or conditionals. You must invoke the algorithms using the same interface. And the interaction between the concrete strategies and the context may require the addition of methods that get to the context. If that gets to be overly busy, you can pass the context if the context implements a specific interface for what the concrete strategy needs. And so the class that uses the algorithm should be an abstract class, and each derived class implements a specific algorithm as needed. A detail is that your abstract method won't be abstract if you have some default behavior in that quote abstract unquote method. And the responsibility for selecting which implementation of the strategy is done by the client object and is given to the context object of the strategy pattern. So it breaks down into this UML diagram here. Client configures the context selects a strategy and has the information that the concrete strategy needs, and that's how it's organized. He has some examples of some things that he has run into. And someone says, well, in the UK, people of a certain age don't get taxed on food. And so he comes up with a number of ways of passing the additional information on that, how that's needed. And he evaluates each one. You could pass the age of the customer to the calc tax object and use it. Each strategy would use it if it's needed. That's one way. You can be more general by passing the customer object itself, and the strategy can query it if it needs it. Or you can be so even more general by passing a reference to the sales order and letting the calc tax object query it. And which one you choose kind of depends on you know, how generally that additional information is going to be used by the other concrete classes and so forth. So it's going to be evaluated on an individual case.
It's interesting. So I'm looking at that, and I'm thinking what we should do next is refactoring, because those are named refactoring. There's like replace values with value objects, something like that one. Basically, when he said move it to general, that's a name refactoring. And the beauty of that, which is not really here, but when you look at how we categorize refactoring, they say, hey, what is the smell that you're getting? Oh, I'm trying to add more and more parameters. Like what age? Then I put address. Then I put social security. Well, then at that point, maybe you should pass in the object, which could be, in this case, the customer object, or if you need even more stuff, the one. So it's really good to see how they all like reinforce each other. Yeah. And the emphasis on why you should really study all this stuff, because some people have already made all the mistakes and figured out the lessons for you. Yep. And if you just sit there and decide that you want to invent it all yourself, then you'll be where they were 30 years ago. Yep.
Okay, so so he discusses some considerations. He says, although it's true I have to modify the sales order calc tax classes to handle the case, it's clear what he wants, what he needs to do it. He's not going to introduce a problem immediately, but I agree with Forrest. It maybe needs some more refactoring because the classes could start growing and start having more than one responsibility. Technically, encapsulating the business rules. I like when he says he's found it can be used for encapsulating virtually any kind of rule. And so when he starts thinking about implementing different rules at different times, the strategy pattern starts popping up in his mind as perhaps a good thing to use. The strategy pattern requires that the algorithms, the business rules being encapsulated, lie outside of the class that's using them. And that is, you know, keeps things loosely coupled and clean. One of the things I really like, being kind of a QA engineer, is it really simplifies unit testing, because you don't have to isolate all of these unnecessary interactions that should not have been there in the first place. So each of the implementations can be is in its own class and can be tested through its own interface. This makes testing much faster, and much faster to not only implement, but they'll probably run a lot quicker too. Okay, so if several different families of algorithms coexist, I'm not sure what he's saying here. You don't. Oh, he's saying you don't. He's saying you can. All right, I'm going to pass this to the field. Anybody have a good interpretation of what he's trying to say here?
I think he's just talking about basically the encapsulation you do for a strategy pattern allows you to have different things that coexist because the encapsulation is localized. I.e., if you didn't do strategy, you had all these ifs and objects, you might have like 12, 13 variables that might have overlapping things, right? But since each strategy gets separated in its own object and they can hold their own state, they don't overlap. So in my mind, this is a general, well, if you do good OO, and you keep your data and your behavior together, then you can have a bunch of these and they don't mess with each other. But if you do the typical beginner programming, I got one thing and I start all my variables and I have all these methods and I have potentially overlapping variables or whatever, you break it. So, and kind of related to a lot of these, I look at encapsulate what varies. If you did single responsibility principle, that kind of leads towards that.
Yes.
Like you look at sales order and tax. Well, tax is its own thing.
Yeah.
It's a single, well, it should come out as its own thing because it's a single responsibility. The ideal about other sales order stuff and tax, well, then that's too big of an object. So just the idea of following that one leads to some of these things. Right? And I see that statement saying, oh, yeah, they can coexist because everything's encapsulated. Which, if you're not in the habit of doing that, you can muddy things up because you tend to have less encapsulation, like the anti-patterns of God class. I got this gigantic class with 9,000 methods and 9,000 members, and and then I start, I use 0 something twice in 2 different methods, and now I'm stepping on each other, and I called this and I called that. Oops. But if they're a separate object, you'd never see that.
It's interesting. I don't remember him using the term single responsibility principle.
But I was just thinking him talking about variability in this case.
Yeah.
Sales and tax. Those are 2 different words. They're 2 different objects. Right.
But I think it would be it would be useful if he would introduce that. Because this is the embodiment of the single responsibility principle. Okay, so he had the task controller pass the strategy object, the sales order, each time it was needed. If he was reusing the sales order object for different customers, he would always use the same strategy object for any one particular sales order object. And he's got a variation, is to assign the strategy object to the context of the strategy pattern, in this case, the sales order object. Then any method that needs to reference it can, without requiring it to be passed in. Context still does not know what particular type of strategy object it has. And so the context is still isolated from the implementation itself. And so the strategy object itself, as long as it's known at the time the strategy object is constructed, the isolation is still there. Yeah, I've seen this so much in my early, you resisted creating classes because it seems like every time you created a new class, things got worse because you were doing it all wrong. And so there's a whole period of object-oriented programming where you do minimal classes because things would just get worse.
Well, I think it's Yagni. If you don't need it, don't do it.
Yeah.
It's just people don't know when that line is.
Right.
Because the problem with patterns is you necessarily increase complexity. So don't introduce them if you don't need it. Because the opposite is people who learn design patterns, they write too many. I mean, you look at J2EE, 9 million classes. There's that joke thing from like 20 years ago. Oh, this is Hello World in J2EE, and it's like 23 pages of crap.
Yep.
And it's like, oh, see, that's what people do, and you kind of have to do that to realize, oh, that's crazy. But you don't know it's crazy until you've done it.
Right. Okay, so he has suggestions for C++ and Java. And so I'll let those go. So in the summary, strategy pattern is a way of defining a family of algorithms. Each algorithm is an implementation of SRP. And what's really nice is they have much more opportunity to do it cleanly because they don't have to worry about anything else. He's illustrated this with a family of tax calculation algorithms. And so he talks about how the strategy allows him to encapsulate these rules in an abstract class and be implemented in a family of concrete derivations. It keeps loose coupling, makes for easy maintenance, easier testing. And he flags a future thing in chapter 16. He says, but you also have to manage those variations, which I'm going, okay, I'm looking forward to chapter 16. And with this, we've got 3 minutes left. And here's where we're going to, if you've done this, anybody done the exercises?
Can we get them in 3 minutes? I don't know. I realize, I think we're supposed to start this with questions from chapter 8.
Oh, okay.
Before we jump into yours. So I don't know if we delay and do all the questions next time, taking like observation, intense, these are kind of important. I mean, when I look at observation, that's a good review, interpretation, variable, phase, opinions and things. These are all, it's all.
Should we move it to next meeting?
Yeah, let's do it. Let's actually discuss it. Ironically, we'll probably do 8 and 9 questions as long as I don't forget to do that at the beginning.
I'll remember.
So no, when I look at it, it's like it really never hurts to review the basics. And it seems like it's because people don't remember drill. And I'm seeing these and other things. I'm doing a lot of these days, martial arts and music. Of course, like, the better your core basics are. I said, you really can't be too good at it.
Yep.
People, I think the mistake is people think they're too good for that. And they go and make all these dumb mistakes simply because, oh, I know that. No, you don't. But, we all think we're experts at everything. Because we have the best words. So, okay. So I'm going to wrap this up, I guess, a little early. We'll pick up Leslie's questions. So I'll set up next appointment. And
who's got the next one?
Oh, yes. Who should take the next one? What's the next chapter? What's the one after this one? It is chapter 10. Bridge. Oh, the bridge is complicated.
I wish I'd chosen that one. I read it. It's very cool in what it accomplishes.
Bridge is a complicated pattern, so we should have someone more, well, in theory, we should have someone more sophisticated, not necessarily more experienced. Is it the kind of thing you throw at a less experienced person?
I think it explained it really well.
And I say that because I'm less likely to have insights like, oh, yes, I tried this and blah. And I think that's where a lot of the value, I mean, study groups in general, the value is, okay, here's the text, now let's find some real life experiences that hopefully you can say, oh, I sympathize, or that was almost a problem I had. Make it a little realer. So if you give that to, say, Andrew, who has never heard of the bridge pattern before 3 minutes ago, not likely to produce those kind of insights. In fact, maybe, I don't even know if sometimes, I'm seeing there's a lot of stuff like sometimes you're not ready for certain info. That's nothing people don't like. No, I'm always ready. So no, I'm seeing that all the time. You're not ready for a certain presentation if you don't have a certain background. Sorry, who's doing it? Should we throw it? Who?
Volunteers.
Brett just went. Andrew kind of went recently, and I'm kind of excluding him. Sam already left, so I might assign him, but I don't know if he'll be here. So I can't assign it to someone I don't know.
How about Diego? He's not there.
Diego goes. So make Diego do it. When's the last time Diego went?
I think that's fair.
Oh, okay. We'll go with that.
So if you leave early?
Brett says Diego gets it.
Plus, I love assigning Diego stuff.
Yes. All right. Well then, thank you and good night.
Yeah.
Thank you for coming to Nested Loops, and we'll see you in 2 weeks. Bye.